I'm Grace. I'm a solutions architect in the cloud platform team, and I'm here to talk to you about DR. So why are we talking about DR? Well, if you're responsible for the availability of your systems, then you've probably had a conversation something like this. How many of you have lived that picture? Yeah, quite a few of you. So I'm now going to kind of delve into some of the patterns and things that you can do here. So you'll be aware that whenever you start talking about DR, there are some three-letter acronyms or TLAs where you usually start. I'd like to start off by distinguishing between DR and HA. Think of HA as being for micro disasters. A single server dies, a disk fails. Whereas DR is for a larger disaster. A huge chunk of your production systems break down and you need to fail over to a different location. Natural disasters also fall under there. So there is a relationship between the two, and in some cases, particularly when running your production workloads on GCP, you will see how HA influences your DR strategy. For example, using GCP's global load balancer means that if a region becomes unavailable, your application just keeps on working. When we talk about DR, there are two main terms that you need to understand. First, there is recovery time objective, RTO, which is directly related to how long it takes to get your application back online. It is determined by what strategy you adopt. This value is usually defined as part of a larger service level agreement. Secondly, there's recovery point objective, RPO, which relates to the amount of data at risk. Ultimately, it boils down to how much data can you actually afford to lose. Think of it as the last backup or checkpoint you can roll back to. This metric will vary based on the ways the data is used. For example, frequently modified user data could have an RPO of just a few minutes, as you probably have the transaction logs that you can roll back to. Whereas infrequently modified data may have an RPO of several hours if you need to restore maybe last night's backup. Note that this metric describes the length of time, not the amount or quality of the data. So taken together, these metrics have a roughly asymptotic impact on your bottom line, which means that the smaller your RTO and RPO value, the more your application will cost to run. SLA and SLO are normally conflated, but the key here is that the SLA is the entire agreement and specifies what service is to be provided and how it's supported, times, locations, costs, performance, penalties and responsibilities of the parties involved. Whereas SLO are specific measurable characteristics of the SLA, such as availability, throughput, frequency, or quality. An SLA may contain many SLOs. We'll keep those definitions in mind as we look at some of the patterns and implementation details for the scenarios. Before we explore the approaches you can take, let's take a quick look at some of the production and key features, some of the products and key features that the GCP has available to help you implement your DR strategy, no matter where your production workload is. So it's a little bit of an eye chart. Cloud storage. This is an object store. Great for storage of backup files. Cloud load balancing provides a single globally accessible IP address to front your back-end instances. It's global, so your application can have instances running in Europe and the US, and your end users will be directed to the closest set of resources. GC instances and images, the workhorse of the cloud. These are virtual machines which you can take incremental backups of or snapshots of that you can copy across regions. You can create custom images with your application. You can then use them to launch instances from. Managed instance groups working in conjunction with GLB provides a way to distribute traffic to multiple copies of identically configured groups of instances spread across multiple zones. DNS, Cloud DNS provides a programmatic way to manage your DNS entries. Deployment Manager allows you to define your GCP environment in a set of templates that you can then use to create complex environments, and simple ones as well, with a single command repeatedly and consistently. Equally, you can tear the environment down with a single command. Network connectivity options. To transfer data to and from GCP, you need good connectivity. So we provide you with choices of how you can do this. We have a variety of connectivity options, and it's more than likely that you will choose Cloud Interconnect or Direct Pairing to connect through to GCP for your DR configurations. So you have a reliable link, and we're not dependent on the variances of traversing the internet, where there is no control on the hops between your on-premises and GCP. I think we're in good shape now to start exploring the approaches you can take. So let's start with looking at DR when your production workload is on GCP and start seeing how we can start using this toolbox. Before I go on, I just wanted to drill into cloud storage in a bit more detail. There are a number of storage classes. The characteristics of the specific class determines the most appropriate use case. So in the DR scenario, nearline is of particular interest to us. Nearline reduces your storage cost, but access costs are higher than standard. It's designed for backup type scenarios where access is at most once a month, ideal for allowing you to do those DR stress tests while keeping costs low. Data is always a good place to start, I reckon. So let's look at the data DR techniques when your data tier is on GCP. It's safe to assume that most of you have databases, perhaps several, and likely you've considered a tiered storage solution. Looking at tiered storage in this context, we are focusing on using it for backups, where you have the most recent backups on faster storage, and then you archive off to backups to cheaper, slower storage. It's a pretty common pattern. So Ben's session this afternoon on building hybrid cloud tiering with cloud storage for backup and archival goes into more depth on using on this technique. Here you can see an illustration of a typical tiered storage setup on the GCP, where we're using the characteristics of cloud storage classes to implement. Inevitably, you'll need to define some rules that describe how objects move between the tiers. Thankfully, GCP makes it easy by allowing you to script a few simple rules, which are known as lifecycle rules. You can do things like downgrade the storage class of an object, older than 10 days, say, delete objects created before March the 1st, 2017, or maybe keep only the 3 most recent versions of an object in a bucket with versioning enabled. That's only half the story, though. And as on premises, you need to think about what happens when you need to do a major upgrade to the database server, say. If so, then you will need to figure out how you can get back to a version on the database server that the backups you stored in cloud storage are compatible with. It's not as onerous as it sounds, though, okay? You actually have some options about what you can do here. We allow you to create a custom image that has the relevant version of the database installed. Before we go into that, I want to talk a little about snapshots. Snapshots are available across regions, which means that if you snapshot your database, you can restore it to a different region as easy as you can restore it to the same region. As you can take regular snapshots of your system, this also means each time you upgrade, you can roll back to the snapshot with the previous version if you need to. As a short-term strategy, snapshots are useful for fast recovery. So back to custom images. When you launch an instance, you start from an image. This can be as minimal as just having the default OS, or maybe having been fully baked and having your application and all your apps installed on it. Decide where on the continuum your image fits. Is it fully baked, or do you want just the OS? Okay. When choosing your baking strategy, you'll need to consider things like boot time and manageability. Fast boot times are a must for auto-scaling web servers, but a database server may not need that fast boot time. Thinking about how the instance will be used in the context of your DR requirements will help you determine what your starting image should look like. Up until now, I've discussed DR techniques applicable when your database is deployed on a GCE instance. However, GCP has a range of managed databases that fit a wide variety of use cases. So you choose to have to use one of these so you don't have to take on the operational overhead of managing them yourselves, as you do when deploying a database on GCE instances. This table lists them together with some sample backup methods. Okay, I've been talking about data backup and recovery, but that is only half the story. You also need to consider the DR strategy for your application or service that uses that data. The techniques I've already discussed, like snapshots and the concepts discussed with images, are all applicable. We need to bring your application and your data recovery techniques together and look at the bigger picture when designing the strategy. The typical way to do this is to think about your RTO and RPO values and then what DR pattern you can adopt to meet those values. So DR patterns are considered to be cold, warm, and hot. Think of these as being how ready you are to recover from when something goes wrong. Think about what you could do. Think about what you would do if you had a puncture. How you deal with it depends on how prepared you are. And we can draw an analogy with the cold, warm, and hot patterns. So you're driving along, you have a puncture, but you have no spare tyre. So you need to call someone out to come out to you with a replacement tyre, and then they have to fit one. You have to wait until they arrive. Moving along the continuum, the equivalent of a warm pattern would be if you had a spare or kit. So yeah, you do have to stop, but you can fit the tyre or fix the tyre or replace it, and then you're on your journey. So you've had a bit of a break. But if you have a run flat tyre, yeah, you need to slow down, but you don't stop. There's no real impact on your journey, okay? So it's just basically the idea of how ready you are, and therefore how quickly you can recover. So let's look at a few examples of how you can apply these patterns to production workloads on GCP. This cold pattern example requires you only ever have a single instance up and running. Here, the serving instance is part of an instance group, and that group is used as a back-end service for an HTTPS load balancer. The heartbeat and snapshot instance is part of a managed instance group. Managed instance groups are a group of identical instances which work with load balancing services to distribute network traffic to all of the instances in the group. The managed instance group is controlled by a GCE autoscaler. The autoscaler is configured to keep exactly one instance running at all times. If it fails, then another identically configured instance is launched in its place. The heartbeat and snapshot instance runs a cron job at regular intervals to snapshot the serving instance, and it also checks the health of the serving instance at regular intervals. If the heartbeat and snapshot instance detects that the serving instance has been unresponsive for a specified period of time, it instantiates a new serving instance using the latest snapshot and adds the new instance to the managed instance group. When the new serving instance comes online, the HTTPS load balancer begins directing traffic to the new instance. Looking at this warm static example, you can see how we're making use of cloud storage to provide a DR solution for a web app running on Compute Engine. In the unlikely event that you are unable to serve your application from Compute Engine instances, then you can mitigate service interruption by using a cloud storage-based static site on standby. In the normal configuration, Cloud DNS is configured to point at this primary application, and the standby static site sits dormant. In the event that the Compute Engine application is unable to serve due to a problem, you would simply configure Cloud DNS to point at the static site. This implementation of a warm pattern is one of those patterns where the cloud has encouraged you to think differently. If you do not need all those wiggly moving parts all the time, this could be the pattern for you. A hot pattern, when your production is on GCP, is basically a well-architected HA deployment. In this example, we're making use of a regional managed instance group together with load balancing and Cloud SQL. As I mentioned earlier, managed instance groups are groups of identical instances which work with load balancing services to distribute network traffic to all of the instances in the group. In this example, we are using a regional managed instance group, so we have instances that are distributed across 3 zones. Now, what's really cool about regional managed instance group is that you get HA in depth. It provides mechanisms to react to failures at the application, instance, or zone level. And you don't have to manually intervene if any of those scenarios should occur. To address application level recovery as part of setting up the managed instance group, HTTP health checks are configured that monitor and verify that services are running properly on the instances in that group. If a health check determines that a service has failed on an instance, the group automatically recreates the instance. Moving up the stack, if an instance in the group unexpectedly stops, crashes, or is deleted, the managed instance group automatically recreates the instance so it can resume its processing tasks. And if for some reason a zone becomes available, you do not have to intervene, as by using a regional managed instance group, there will still be instances available serving your application. The global load balancer accepts traffic through a single global external IP address and then distributes traffic according to forwarding rules you define. You set up health checks here to ensure that new connections are only load balanced to healthy instance that are up and ready to receive them. In the data layer, we have Cloud SQL, which is configured for HA. So we have set up a failover replica in a different zone from the master. All changes made to the data on the master, including to user tables, are replicated to the failover replica using semi-asynchronous replication. If the zone where the master is located experiences an outage, Cloud SQL automatically fails over to the replica and your data continues to be available to clients. Existing connections to the instance are closed, but your application can reconnect using the same connection string or IP address, as you don't need to update your application after a failover. After the failover, the replica becomes the master, and Cloud SQL automatically creates a new failover replica in another zone. This architecture is a great example of why, by using services that provide HA facilities, your application can automatically recover when things go wrong. Okay. My favorite tool, the DR toolbox, is Deployment Manager. It allows you to define what your environment should look like using Ginger templates and Python. With a few clicks or a single G-Cloud command, you can bring up an environment within minutes. Let's see Deployment Manager in action, bringing up the HA web application we just looked at. I'd like to welcome Oleg. Oleg! One of my colleagues based out of our Amsterdam office is going to drive the demo for us. Oleg, thanks. That's Wizard, by the way. He's our office dog. And he's human. I did pay him, by the way. I gave him dog treats for letting me use his picture. OK, so the first thing Oleg is going to do is download a set of deployment management templates from a bucket, and he's going to deploy it using the G-Cloud tool. So Deployment Manager uses a set of declarative templates that let you consistently deploy, update, and delete resources such as GCE, GKE, and cloud storage, for example. Typically, you will have at a minimum a configuration file and one or more template files. Schema files are also usually part of the parcel. They allow you to declare a set of rules and configurations. In a set of rules, a configuration file must meet if it wants to use a particular template. OK. All right. So templates, as I mentioned, can be written in Ginger or Python, your choice. Ginger is simpler, but less powerful than using Python. Using Python gives you the ability to programmatically generate the contents of your templates. You could pass variables to your templates, which make them easy to use. We set up the Cloud SQL backend up earlier, because in reality, you're not likely to recreate your database environment from scratch in a DR scenario, so we didn't either. Okay. Bearing in mind, if you don't have a database ready up and running, not only would you need to create the databases, you'd also have to load it with data. And it would affect how long it takes to recover, and that's what RTO value you have. It wouldn't be a small value. In any DR pattern that involves a database of some kind, that tends to be the overarching recovery process that dictates the achievable RTO. Okay. Right, so can we look at the autoscaler template, she says. So we don't need to gather around his laptop, that's good. Okay. So if you look at this template file, you'll see that we've declared the minimum number of replicas that the autoscaler can scale down to is 3. We can switch to can you switch to the GCE console, please?
Yes.
Okay. So remember we said 3. So you can see we've got 3 instances there. All right. Can you delete one of them now, Oleg? Go nuts. So as we have auto-scaling on, it will automatically replace the instance that Oleg has just deleted. Okay. I spoke earlier about HA in depth, using managed instance groups together with auto-scaling of groups being a key tool. Okay. So here we're demonstrating its capability at the instance failure level. But equally, we could set up a HTTP health check that we set up against the group. If that detects that the actual application running on the instance fails, it would automatically create a new instance and delete the failing one.
So
okay.
Deleted.
If you're using, thanks Oleg, if you're using a load balancer as well, you can also set up health checks here too. But load balancer health steps will just stop serving traffic. They don't actually remove the instance. They don't delete them. Okay. So you need to understand how to set up both types of health checks. The rule of thumb is to be more conservative when setting up health checks against the managed instance group. Okay. So as you can see, the replacement instance is coming up. Right.
Yep, it's up.
As there isn't actually, yes, we got there in the end. Sorry about the delay. As there isn't actually anything wrong with the zone, the replacement instance got launched into the same zone as the one we were deleted. So anyone who was paying attention and noticed the zone, you would see it's put it straight back into the same one. All right. We can easily after that, we can easily tear down the deployment by just deleting it. So, okay. So this is great if you're doing test stress of your DR environment, which you should do. You know, so I understand, having been there myself, is the fact that doing full-scale tests are difficult. This just makes life easier. You know, you've seen it in, you fired up the environment, we pulled it down as well. So you're not actually having to invest in lots of stuff that's staying there that you don't use very often. And then you're worried because you don't use it very often, why hasn't it come up? You know. So moving on.
Yep.
Okay.
Bye-bye.
Sorry. Okay, thank you very much, Oleg.
Yeah.
Thank you. Thanks, Oleg. Okay, so moving on, let's look at DR when production is on premises and your recovery site is cloud platform. So I've been covering when your production is just on GCP. When you're using GCP as the recovery site for your on-premises workload, there are a few key things you need to consider. The initial question usually being, how do you connect to GCP? GCP provides a number of ways to connect from on-premises, cloud interconnect being the ideal way to provide a consistent, reliable link. You need to take into consideration factors such as the bandwidth between you and the carrier interconnect provider, as well as the actual bandwidth provided by the provider directly to GCP. Think about what other data will be using that link. Consider how much data has been transferred and how long have you got to meet any RTO values. You can see from this table, by the way, which isn't taking into account any external factors at all, that bandwidth availability does have a direct effect on the time it takes to transfer data. Don't forget to take into account your security controls. You may determine that you want total control of your encryption keys, so factor in the end-to-end encryption-decryption process. Who will have access? Think about authentication and authorization mechanisms. How much can you automate? Remember, everything is an API, so you don't need to rely on an actual, probably sleepy human to start bringing up online your DR site. I know whenever I had to instigate a DR scenario, it was always in the middle of the night. I was always half asleep. Okay. So when taking a traditional approach to DR on premises, it typically involves somewhere in the process people driving vans and swapping tapes around. The tapes usually, or should I say hopefully, being the offsite backup. Remember, okay. Sorry, don't know what's there. Remember this? Well, we can use the same tiered storage approach to replace the need for tapes and vans moving tapes on and off site. We can replace the source to be your on-premises storage appliance, for example. So here, you need to set up connectivity to GCP. In this example, we're using GCP's Cloud Interconnect service. You can then implement a process to copy data from the storage device to a cloud storage bucket. This process can be very simple using, say, the gsutil command. You may also want to set up a GCS lifecycle rule, like we described before, to delete data and move to a cheaper storage class. Here's an example of a cold pattern. In this example, we have practically nothing running in your target GCP project. When there's a problem that prevents the production environment running production workloads, you deploy a deployment manager template to create an environment capable of running production workloads. Note that we were trickling data into cloud storage as part of that production environment. You'll need to implement processes to restore the applications to all the instances spun up. So think back to the continuum of images we spoke about earlier. You'll also need to think of a way to transfer data from cloud storage to the database you spin up in GCP when you invoke your DR plan and start serving production traffic from your GCP environment. This pattern may be the most cost-effective, but it has the highest RPO and RTO values of the patterns and requires the most operational effort to recover from. Moving on, here's what a warmish standby setup could look like. Here we have a multi-tiered application running on premises while using a minimal recovery suite on GCP. Ignore the Cloud SQL instance for a moment. I'll come back to that. You can see that a database server instance is running on the GCP side. The instance must run at all times so that it can receive replicated transactions via asynchronous or semi-asynchronous replication techniques. To reduce costs, you can run the database on the smallest machine type capable of running the database service. As this will be a long-running instance, sustained use discounts will apply. When the on-premises application needs to fail over, you can make the database system on GCP production ready. By destroying the small database instance, making sure to keep the persistent disk containing your database system intact. If your system is on the boot disk, you will need to set the auto-delete state of the disk to false before destroying the instance. Create a new instance using a machine type that has appropriate resources for handling a production load and attach the persistent disk containing your database system to the new instance. In the event of disaster, the monitoring service will be triggered to spin up the web tier and application tier instances in GCP. You can then adjust the cloud DNS record to point the web tier, which in this example will point to the external IP address of the HTTPS load balancing service. Okay, so coming back to that Cloud SQL instance. If your on-premises database is MySQL, you can use a Cloud SQL replica instead of the VM instance, and data is replicated directly from the external master to the Cloud SQL replica. For smaller RTO values, you could adjust the above strategy by keeping all of the compute engine instances operational, but not receiving traffic. This is not cost-effective, but may be an option that meets your needs. You may want a ready-to-take-over production workload database instance, so you can omit the resizing of your instance. In this pattern, you'll notice that you have to replicate the data to your database. This is one way of ensuring your DR failover database is kept up to date. There are other options for keeping your recovery database up to date. The methods you choose will have a direct impact on your RPO value. You may choose to apply backup and transactional logs as your data recovery strategy. This means you do need to keep copies of the transaction log files as well as the backups. You need to regularly restore backups and apply transaction log files to your recovery database and test that it acts just like the production database. Exactly how you implement this depends on the flavor of database you're using. Maybe you have a read copy that can be promoted similar to the techniques we discussed when using HA Cloud SQL. You could choose to keep a copy of the raw data on cloud storage and rebuild them, assuming your RTO was long enough to allow that. What happens when you've fallen over to your DR database? How do you then get your production database back up to date? In many cases, it's just the reverse process you've been following to keep your DR database up to date. Data recovery is tricky, and you need to run regular fire drills and be totally confident that you can happily run production, whether you are using your production database or your DR database. Take advantage of Cloud Deployment Manager to spin up your failover application, point it at your DR database to validate, and once you're done, you can tear down your replica environment down until it's needed for the next fire drill. If you have very small RTO and RPO values, then you could take that warm pattern and modify it so it's just an HA across with GCP, which gives you a hop pattern as both on-premises and GCP are serving production traffic. The key differences from the previous pattern being that everything is running in production mode and serving production traffic. The GCE instances are part of a managed instance group behind a load balancer, and the GCP database instance is production ready. If you do choose to implement this type of hybrid approach, be sure to consider a DNS service that supports weighted routing when routing traffic to the two production environments, so that you're able to deliver the same application from both. In the event that one environment becomes available, you can then disable the DNS routing from the unavailable environment. So we've discussed several examples of using production workloads on GCP and on-premises. I'm just going to discuss briefly now what techniques you can adopt when you're running production across clouds. If your application involves virtual machines running across different clouds, again, you have to figure out where on the continuum your images are for both clouds. You'll want to use tooling that works across them both. If it's a fully configured image required, consider something like Packer, which can create identical machine images for multiple platforms from a single configuration file. You can use something like Terraform, which, it's a cloud-neutral templating tool. Okay, so you might want to, if you're just running on GCP, you use the native tools. If you're running across clouds, you need to find something that runs across both of them. You could use configuration management tools such as Chef, Puppet, Ansible, SaltStack to configure your instances. Or even to configure the instances that you will use to create the images you'll be using. That's a very common technique, and it keeps everything consistent. If you need to, you can set up a VPN between clouds. If you're using containers, you know what I'm going to say. There's only one thing that needs saying, it's Kubernetes. With Kubernetes, you can federate across clouds. You can use GKE, which is Cloud Platform's fully managed Kubernetes environment. And then on, say, Azure or AWS, you can use Kubernetes on there. Okay? There are other techniques and solutions to the ones I've just discussed that you can implement for multiple cloud scenarios. For example, if you want to replicate data from AWS S3 to cloud storage, then you can do this easily as well. Maybe by using Boto, which is a Python tool designed to work with AWS, which also supports cloud storage. There's plenty of ways to do that. It's not going to be easy. I'm not going to deny it, but you can do this. Okay. So just to recap, why using GCP is the destination you should be thinking of for your DR needs. It improves your TCO. It's easier to carry out the fire drill, so you will have a greater degree of confidence that in the unfortunate situation you have a disaster, then, like Wizard here, your ops team will be calmly executing the recovery process. Also, you don't need to keep rethinking patterns. They apply no matter where your production workload is running. So there you have it. If you're thinking of DR, either to revamp your current solution or wanting to actually implement a new DR solution, hopefully we're giving you plenty of ideas.